A capacitor and a resistor are connected in series together with an AC source. The voltage across the capacitor is given by the sinusoidal function. The first question is, what is the capacitive reactance of the capacitor? Let's apply the formula. The capacitive reactance X sub C is equal to 1 over omega times C. Omega is the angular frequency of the AC source, and C is the capacitance of the capacitor, which is given. Now, how do we determine omega? If you look at the function that represents the voltage across the capacitor, this value here, 7.1 volts, that is the amplitude of the voltage across the capacitor. That's the maximum voltage that the capacitor has. And then it's being multiplied by sine omega t. So 130 radians per second here, that is omega, which is the angular frequency of the AC source. After the numerical substitution, we get X sub C equals 1.7 times 10 to the third ohm, or 1.7 kilo ohm. Note that the capacitive reactance or also inductive reactance both have the same unit as the resistance, which is ohm. Now let's calculate the potential across the resistor as a function of time. Potential across the resistor is equal to the resistance times current of the circuit. Again, the current is lowercase I because it changes with time. It depends on time. How can we express the current in the circuit? It's going to be equal to the amplitude of the current, capital I, times, you can either do sine omega t plus 90 degrees because the current is leading the capacitor voltage, or that's equivalent to cosine omega t. So either way works. Here I have expressed V sub r in two different ways. You can either use sine. In that case, you would have to add a phase difference of 90 degrees or pi over 2. So that's sine omega t plus pi over 2. Again, why? Because the current is leading the capacitor voltage by 90 degrees, and the resistor is in phase with current, so it is the resistor also is leading the capacitor by 90 degrees. Or sine of an angle plus 90 degrees, that's the same thing as cosine of the same angle. You can use the cosine format, which is more common. So then VR, the voltage across the resistor as a function of time, is equal to the resistance times the amplitude of the current times cosine omega t. Now the amplitude of the current is not given in the problem. However, we know the amplitude of the voltage across the capacitor, and we have also calculated the capacitive reactance X sub C. We can use those two to calculate the amplitude of the current. The voltage amplitude for the capacitor, capital V sub C, is equal to capital I, the current amplitude, times X sub C, the capacitive reactance. We isolate I and we get V sub C divided by X sub C for the current amplitude. And then we combine everything and substitute the numerical values. After the numerical substitution, we get V sub R equals 1.0 volts times cosine of 130 radians per second times T. Again, V sub R, that's the time-dependent voltage for the resistor. 1.0 volts, that's the voltage amplitude of the resistor, and 130 radians per second, that's the angular frequency of the source.